Welcome to yet another video about finding power in a circuit. So this time we're going to be finding power as well, also this time, but the circuit is going to be different as always. So let's crack on and draw our new circuit. So in our new circuit, we are going to have a current generator, and then up here a resistance, and then here we will have another resistance. Down here, this one will be my point B. Down here we'll have another resistance. There we go. And this one will be my point A. And then I will have here another resistance, and here a generator of voltage, which I'm gonna call plus E1 minus. Whoops, E1 minus. Then down here we will have yet another resistance, and here again another resistance as well. Oops. There we go. This one is gonna be my point C. And I'm gonna call this generator of current J1, and resistances are gonna be R1, R2, R3, R4. Well, no. This I can call this RA. This is gonna be R4, and this is gonna be R5. So I'm gonna say for the circuit on the left, we know that what do we know? Well, we know that EA, let me just call this EA and RA. So we know that EA, so this generator of voltage here, is equal to 75 volt. J1, so this guy here, let me just, there we go. I'm just gonna make a little bit more room here, otherwise I wasn't actually able to write properly because I have many stuff in my desk. Yeah, I should have been, which is not actually a desk, it's a table, but I'm using it as a desk. Anyway, so as I said, J1 is actually gonna be 6 amperes. Okay, so J1. Then we know that R1 is 12 ohms. R2 is 20 ohms. R3 is 30 ohms. R4 is 90 ohms. R5 is 60 ohm, and RA is equal to 10.5 ohms. Find the power dissipated in the resistance RA. So this resistance here. Okay. Now I'm basically gonna, first thing first, I'm gonna draw the circuit in which only the current generator J1 is acting. And I'm gonna substitute the points A, B, and C, those 3 points here, that are basically in a triangle. Okay, A, B, and C are in a triangle. I'm gonna substitute the triangle with a star. So basically the triangle, many of you perhaps know about the triangle as delta, because delta is basically a triangle. So those three form a triangle, and I'm going to substitute the triangle with star. So let me just do that. So in this new circuit, I'm only going to have the generator J1. Then here at the top, I'm still going to have the resistance. I'm still going to have this point here. And here still going to have the resistance. This one is still going to be my point B. Down here I'm still going to have the resistance. And down here I'm still going to have my point A. Here I will still have the resistance, but here I'm not gonna have anything, just a straight line, so just as if it was a short circuit, instead of having the voltage generator. Then down here was the resistance and the other resistance. But it will be as if they were connected, as I said, with a star. So a star, especially this one, with a point A, B, and C. And this will still be my R4, R5, R2, R1, and R4, and RA, sorry. And then I'm gonna say that I'm gonna say that the current going here, or the current going here, I will call this I. So in this new circuit, the current going here, I'm gonna call this I first. The current going down here is gonna be my I2, and the current going down here is gonna be my I3. So now the idea is to find RA first. So, and then to find, well, it will be to find RA, RB, and RC. So RA will be R4 times RA over RA, RA with a capital, and RA, not like R alpha, over R4 plus RA, capital A, plus R5. So if we plug numbers into this, we will have that RA will be, well, 90 times 10.5 over 90 plus 10.5 plus 60. So let me just grab a calculator. So basically we'd have 90 times 10.5 and lays in 145 over, just to show you my degree of laziness, 19 plus 10.5 plus 60 is 160.5. So if I divide those two guys, I get 945 divided by 160.5. Well, 5.88. 88 ohms. There we go. So RB instead will be RA times R5 over R4 plus RA plus R5. So RB will actually be 10.5 times R5 was 60 over R4 was 90 plus 10.5 plus 60. So RB will be 10.5 times 60, 630. This one down here, we know that it's going to be 160.5 because we have done this before. So RB is 630 over 160.5, which is 3.92 ohms. And then RC is actually going to be R4 times R5, everything over R4 plus RA plus R5. So RC is R4, which was 90 times R5, which is 60 over this whole thing. So 90 plus 10.5 plus 60, just like before. So RC is just 90 times 60 divided by all those things. So 90 times 60 is 5,400 over 160.5. It's gonna give us over 160.5, 33.64 ohm. Thanks God we have calculators. So yeah, in this case, yeah. So with the can actually find I'm interested in I2 in this moment. So I'm basically gonna say, okay, I found the resistances, so I can say that I2 is gonna be equal to J1 times R3 plus RB over R3 plus RB plus R2 plus RA. So I2 will be J1, which was 6 amperes, so 6 amps, times R3 was 30 ohm plus RB 3.92 ohm over R3, so 30 plus RB 3.92 plus R2, which was 20 ohm, plus RA is R 5.88. Yeah, I should have been writing this one as RA, capital A, because now it almost looks like RA, these RA. So anyway, two different things. Anyway, so I2 is going to be 6 times, well, shall I grab the calculator? My lazy mind says yes, so let me just say, well, the first one is pretty straightforward. Is 30 plus 3.92 is 33.92. Over will be 33.92 plus 20 plus 5.88 will actually give me 59.8. So I2 will be 33.92 times 6, everything over 59.8, 3.40. Yeah, I'm just gonna write 3.4 amps. So now I can say, okay, this node, I found the current I2, which is this one, and it's 3.4 amps. Okay, this one current here. Now this point here, which is a node, and I just call this N, I'm gonna apply the Kirchhoff current law to this node. So if you remember what the Kirchhoff current law says, it basically says that the sum of the current entering a node is equal to the sum of the current leaving that node, so going out from that node. In other words, if I apply, should I go to the other page? Yeah, I should really go to the other page, but I'm just gonna say, I'm gonna go back to the picture, don't worry, before doing that. So this is say, I'm gonna apply the Kirchhoff current law to node N. So if I apply the Kirchhoff current law, I can say, okay, let's see. We have J1 entering the node. Then we have I2 leaving the node, and also I3 leaving the node. So let me just, this will be J1 into the node. This will be I2 out from the node, and this will be I3 out from the node. So J1 must be equal to I2 plus I3. So as I said, the sum of the current entering a node must be equal to the sum of the current leaving that node, so going out from the node. So J1 gets into, I3 and I2 go out from the node. So J1 is going to be equal to I2 plus I3. So I can basically say, okay, so J1 is going to be equal to I2 plus I3. Now, why did I do that? Well, because we know J1 and we know I2, so our target here is to find I3. So I can basically say that I3 is going to be equal to J1 minus I2. I'm just bringing this one here. on the other side. So if I plug numbers back into this, I will have, well, J1 was, was 6 ampere, and I2 was 3.4 ampere. Therefore, we will have that is equal to 6 minus 3.4 ampere. So I3 will be 2.6 ampere. And now we have found I3, which is pretty good. So we're getting there. Now we have I3, we have I2. I can actually say, I can actually apply the, we have been using the Kirchhoff current law, but you can actually see that this is actually closed. So we can use the other Kirchhoff law, the Kirchhoff voltage law, and we can say, okay, I'm gonna do this for NAB. Okay, so this one here, because this one is like a closed loop. Okay, so we are considering this one, only not this, I mean this one here, as a closed loop. So I'm going to apply the Kirchhoff voltage law to here, and Kirchhoff voltage law to NAB basically gives me, it will basically give me VAB, which is what I'm trying to find, okay, the voltage between A and B, okay, VAB plus R2 I2 minus R3, oops, I didn't write R3, yeah, this is R3, so minus R3 I3 is going to be equal to 0. So again, VAB, which is what I'm trying to find, plus R2 I2 minus R3 I3 is going to be equal to 0. So I can say they can apply Kirchhoff voltage law to NAB, to the closed loop NAB. So as I said, VAB plus R2 times I2 minus R3 times I3 is going to be equal to 0. So VAB, I'm going to rewrite everything in terms of AB by bringing AB and the other one the opposite side. It's going to be equal to minus R2 times I2 plus R3 times I3. So VAB will be, if I plug numbers back into this, well, R2 was 20 ohms, I2 was 3.4 ampere, R3 was 30 ohms, and I3, we have it on the other page, so I'm not going to memorize it. So it will be negative 20 times 3.4 plus 30 times I3, which is 2.6. And luckily we have it in this page. So VAB is actually going to be, well, negative 68 plus 78. Yeah. So VAB is actually going to be just 10 volts. Okay. So now we also have VAB. And the problem was actually all these, because the problem was actually asking us to find the power dissipated by resistance R1. So as we are getting there, the next thing that we have to find right now, and the only current left, is I first, because we have to find it R for RA, and RA is here. So we have found those currents, and the voltage across this. So now we gotta find the current that is going through here, which is I first. So in order, before I do that, in order to do this, this will be just VAB, which is the voltage that we have just found, over RA, which is the value of the resistance, which is given to us by the problem, is 10.5. So let me just, okay, so I first, okay, so basically Ohm's law, it just says that it's going to be VAB over RA. So I first is VAB 10 volt over, was it 10.5 RA? Yeah, 10.5 over 10.5. So I first is 10 over 10.5, is just 0.95 amperes. So now we're not there yet, because we have been if you recall, we have been considering this circuit, but with I first. And the reason why we are considering this with I first is just we had two generator of voltage and a generator on current. So all of this is fine, but we avoided, we basically made the short circuit instead of having the generator of voltage, and we just consider the generator of current. So now I'm going to do the opposite, and I'm going to consider the generator of voltage. So therefore I'm going to find something that is going to be called I second. I know that by now I've been doing this quite a lot. So by now you should be familiar with this procedure, and please don't make me draw again this circuit a third time just to get rid of this and consider this one instead here. Let's just suppose that here we're gonna have I second as well, and we're just considering here this one, and this one is gone. So, and I'm gonna call this current here I second. So if I just considering now EA, okay, which was, as I said, the generator of voltage. So if I now gonna consider EA, I'm gonna get I second, and I second will just be EA, so the voltage there, over, well, will be over EA, so this one here, so as it was this one, EA, will be over R2 plus R3 in parallel with R4 plus R5, everything plus RA. So R2 plus R3 in parallel with R4 plus R5, everything plus RA. So again, if I plug numbers back into this, I will get EA, which is 75 volt, well, quite big. 75 volts over R2 is a struggle when you have to go to the other page, isn't it? All the time. So let me try to memorize it. Okay, so R2 is 20 ohm. No, I'm not gonna memorize. So 20 ohm plus R3 is 30 ohm. In parallel with R4, which is 90 ohm, plus R5, which is 60 ohm. So 90 plus 60. 90 plus 60, 90 plus 60. There we go. Everything plus RA, whoops, which is 10.5. Okay, so I second is, well, let's get rid of all those things. So 30, 40, 50, parallel with 90 plus 60 is just 150, plus 10.5. So I second is well, yeah, 75 over sorry about that, I got cold. 50 times 150 over 50 plus 150, all plus 10.5. So I second is 75, everything over. Well, 50 it would be 50 times 150, which is 7,500. And 50 plus 150, just 200, plus 10.5. Let me just, yeah, I'm gonna simplify everything down because otherwise it's, so 7,500 divided by 200 will be 37.5 plus 10.5. So I second is 75 over 37.5 plus 10.5 will be just 48. So if I divide 75 over 48 will be 1.56 ampere. So now I have been using the superposition of effects by considering first the generator of current and making the generator of voltage as a turning it into a short circuit. And then I didn't draw it again, but I basically considered the generator of voltage, and I consider the J1 generator of current as an open circuit. So by using the superposition of effects, I can say that the I, so the real I here, is given by the sum of I first plus I second. Therefore, I, thanks to the superposition of effects, is I first negative 0.95 plus I second is 1.56. So I is just 0.61 amperes. Therefore, Now, finally, I can find the power dissipated into by the resistance RA, so into the resistance RA, which is just going to be RA times I squared. So the power in RA, which I'm going to call PRA, is going to be RA times I squared. Ohm's third law. P equal R times I squared. So PRA is, RA was, yeah, I have it here. So it's 10.5 times I squared is 0.61 squared. So PRA is 10.5 times 0.61 squared would be 0.61 times 0.61 is 37.21. So PRA is 37.21 times 10.5, which gives me 390.7 watts. So there we go. This is the power dissipated. And again, I hope it helps. If you have any question, please ask me. And see you next time with yet another exercise about finding the power. Cheers and bye.